gonna tag them. I'm gonna tag Desmos on that. I'm gonna say my kids want a shirt that says Desmos Life. All right. Thank you. So let's put it all together here, okay? For starters, I've been mentioning something that we're doing today that I've never given it a name. For example, take a look at this problem. How many roots should I get? 4. Okay? Does that mean that all of them are going to be real roots? I mean rational roots? No, some of them could be irrational or complex, correct? So just really quick, like, since we're already doing this, and I'm just going to jump into it. Today's lesson, 5.6, is supposed to be about this thing called the fundamental theorem of algebra. There are very few fundamental theorems out there, maybe a handful of them. There's a fundamental theorem of calculus. Today we're doing fundamental theorem of algebra. And it's exactly what I've been kind of saying off the grid, or not officially, as we've been doing chapter 5. That the degree of the polynomial will tell you how many roots you will get all together. Some of them real, some of them complex. But you should always get n degree of roots. And they can be a combination of complex or real or whatever. Okay? Also, you should know that it's going to have that many linear factors. So if you have a 4th degree polynomial, how many linear factors should you get? 4, 1 for each root. Make sense? Fundamental theorem of algebra. So let's get back to this problem, and let's do it all. Let's see here. I already know how many roots I'm going to have. How many roots, people?
4.
4. So that's just a little side note. That didn't take me too long. That didn't take me too long. Notice that, I know it hurt. I got it right there. Notice that this is not equal to 0, right? So I'm going to have to move that x squared and that x to the other side. I should get x to the 4th plus 2x to the 3rd minus 13x squared plus 10x is equal to 0. Now I'm going to use Descartes' rule of signs. Did it change signs here?
No.
No. Did it change signs here?
Yes.
That's 1. Did it change signs again?
Yes.
Yes. So how many positive roots should I get? 2. So I'm going to say positive roots equals 2. So how many negatives should I get?
2.
So I should get 2 positives and 2 negatives. Oh, that makes sense because I've got x to the 4th. So let's find those roots. One's really easy. Notice that they all have x in common, don't they? Yes? No? Maybe so?
Yeah.
I'm going to factor out x. That's going to give me x to the 3rd plus 2x to the 2nd minus 13x plus 10. That's equal to 0. I'm going to make a note over here. 1, 2, 3, 4. I already know one of them is 0, right?
Oh, you just factor it out then.
I could. How do I know one of them is already 0?
Because that x right.
Because this x right here. All right? Now, how you choose to go about the others is up to you. If you want to factor by grouping and all the other techniques, I'm going to use that synthetic division one because that's what we were doing in this lesson here. I want to take all the factors of the constant and divide by all the factors of the leading coefficient in this case. So all the factors of 10 are plus minus 1, plus minus 2, plus minus 5, and plus minus 10.
You just put plus minus.
Yeah, you always want to get both the versions in there.
No, you did just plus minus 1, plus minus 5.
Oh, there was supposed to be a 2 there.
Yeah, but
Thank you. It's supposed to be plus minus 2, plus minus 5, and plus minus 10. Now, the factors of the leading coefficient are simply plus minus 1. Do I need to have that there? Answer's no. Because what is 1 divided by 1? What's 2 divided by 1? 2. What's 5 divided by 1?
5.
And what's 10 divided by 1?
10.
So, that just means that these are all my possible options. All right, let's start this synthetic division business. I should have 1, 2, negative 13, and 10. What do you guys want to try first? Negative 5? Sounds good to me. So I've got 1, negative 5. What is that, negative 3? Yeah? Negative 3, so that's negative 15. No, positive 15, which would give me 2, negative 10, 0. Yay! Good job. So that means that one of my roots is negative 5. Should we try the positive 5?
Yeah.
Thank you. Both. Okay. Since I already know I've got this piece of it, I've got x squared minus 3x plus 2. I can keep using synthetic division if I wanted to. But this is already a square, isn't it? A quadratic. At this point, if I wanted to, I can just use my factoring skills. Make this a, make this a 2, make this a 1, negative, negative. Does that work? Sure does, doesn't it? That means that x is going to be equal to negative 1, and x is going to be equal to, sorry, not negative 1. Positive 1 and positive 2. So 1 and 2. 1 and 2. There we go. And there's my two positives. And I guess 0 can't be negative, even if we did put a negative there. So we've just found all of the roots. I'll go ahead and blow that up for you. Z. 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 Morning. I thought it was a snug.
Might as well do the same thing. Where's your tomahawk?
Can I just take the voice class?
No puedo aguantar. Pingüinos congelados.
Oh, yeah. Not $300.
Los mamut.
Hey.
Frozen. A muffin. A pecan muffin.
Look at it.
Amazing. Taking me back. Anybody still writing? All right, moving on. Okay. Here you go, guys. You try now. Find all the roots, please. Give you guys 5 minutes on this. And then I'm going to call somebody. I'm saying who. That'd be nice if I could, huh? You can.
Click on the
That's not fair. I'm very biased. I probably call Ethan all the time.
That's what you first you never put my name here. Came in late, so it's good.
Oh, I'm real? And you never reminded me?
Call it out.
Pencil?
I've never heard that. Come on, left or right.
Okay. That's time. Thank you. I do want to mention something. Thank you, Michaela, for reminding me. That I guess I didn't say yesterday about Descartes' rule. Let's take a look at this real quick. According to Descartes' rule, this is one change. That's no changes. That's a change, so I got another one. That's a change, got another one. That's a change, got another one. I've got a total of 4 sign changes, which means I could get 4 positives. Notice I said could get, and I thought I said that yesterday. That is the maximum number of positives I can have. I can have less than that. I can have less than that. But if I do have less than that, they always go down in pairs. So if I don't have 4 positives, then the next option would be 2 positives or 0 positives. They always go down by 2, so I can have none of them, which is kind of weird. That's why I need to run the negative check as well and get the complement to that to give me an idea. So if I did run the negative, let's say we had, let me move this aside. This is how many positives we're saying we're going to get. Funny. So let's check P of negative x. That would be x to the 5th, x to the 4th, minus 3x to the 3rd, plus 3x squared. Holy smokes, out of space. 5. What was it? 4, 2, and 0. Where am I at? Negative 4x plus 4. We're plugging in a negative x to get those checks. So that would still be negative x. This would become negative x. That would be 3, 4. That would make this positive 3x. This would be positive 3x, negative 4x plus 4. So according to this, I've got no change. I've got 1, none, 1. So according to this, I could get a maximum of 2 negatives. But according to Descartes, I could also get 0 negatives. 0 negatives. So it's either this on the negative side and this on the positive side. Question?
Wouldn't that last change be added to?
Oh, did I not? I missed it? Yeah. Oh, my bad. Thank you. Yeah, none, 1, none. Yeah, so 3. So this would change to 3 or 1. Negatives. Okay? Thank you. Okay, here's my options. What do you guys want to try first? Negative 2. So it's 1, negative 2, negative 3, 6. 3, negative 6, negative 3, 6, 2, negative 4, 0. So there's one of them. Now I'm going to change this. Make another one. 1, negative 3, 3, negative 3, 2. How about negative 1? Does negative 1 work? So 1, negative 1, negative 4, 4, 7. That's going to give me, did I do that right? 1, negative 1, negative 4, 7. Good. So that's going to be negative 10. Which would make it 10 and then 12. So 1 is not an option, or negative 1. I'm gonna put a not list in here. The positive one. Okay, so 1, 1, negative 2, negative 2, 1, 1, negative 2, negative 2, 0. There we go. So I've got a positive 1. One, negative 2, 1, negative 2. What do you guys want to try next? A positive 4? So that's 1, 4, 2, 8, 9. That's not going to work, is it? So 4 is not going to work. How about the positive 2? Well, we haven't tried the positive 2. Did we? No, not the positive 2. So 2, that's 1, 2, 0. 2 times 0 is 0. 1, 2, 0. There we go. So 2 is one of them. Well, I should get 5 roots, shouldn't I? Okay. The only one that we're missing is negative 4. Now, here's the problem. This means that I've got x squared plus 0x plus 1. You guys see that? What two numbers multiply to 1, or sorry, add up to 1, but multiply to 0? 1 and 0? Well, let's do this. If this is equal to 0, we're going to get x squared is equal to negative 1. Notice we got I. So x is equal to plus minus I. And there's our other two roots. So positive I and negative I. But we've got all 5 roots. 3 of them are real. 2 of them are complex or imaginary. Here is the whole caboodle. Yeah, because down here, right, we took the square root of x squared, so we should get plus minus. Yeah, remember the conjugate root theorem? Says complex numbers come in conjugate pairs. That's the one way to do it. You don't eat your peels then? You don't eat the banana peels? Why? A little bit of salt. Some chamoy. Chop it up with some chamoy. I know, I'm just going to switch it. Sorry. I did have a cousin though that ate his oranges whole. Like, grinding it off. He liked it. He liked the bitter of the peel.
Yeah,
Lemons too. Have me some zest, right? See that okay, Blake? Who's gone back there? He doesn't look as crowded. Questions? Any part? No? Guys ready for the next one? Oh yeah! I'll wait for you, Blake. Kill me. I'm not taking it from you.
Yes, you did take it.
Oh, well. Oh, you're talking about your father? I thought you were talking about your blanket.
I sleep with this. I watch it every day. I leave this in my car, and I have another one in my house that I leave in my car.
Yeah, I like when my wife just does a laundry, that softener smell.
So I have a lot of blankets. When I'm waking up sweaty, they be on me.
What?
I went to like his house. Studios, I walked into Lexi's house and her mom said, honey, you might want to take that sweater off. We're not turning the AC on until April. And I was just like, what?
We don't turn on the cooler. I mean the heat for winter, and it gets cold.
I like it like that.
Yeah, the kids get cold, but we're like, just throw on some more pants. Go get some sweats. That's right there. Like, did you get it all? Okay, good. All right, try it again. Let's see what it says. Oh. So find the roots, but also at the end, write it as a product of linear factors. You're gonna need to know how to do that.
I work at Amazon.
That's the one I'm telling you straight up. That's gonna be on the final.
What, dude?
That question right there. I shouldn't tell you, but I just did. How are you gonna put that in my head? How are you gonna put that in my head?
Well, I'm confused.
Time on here? Let's do this one. Please remind me to do that linear factors thing. Okay. How many roots should I get? I should get 4 roots. Roots equals 4. I did find that one of them was positive. Right? Just by using Descartes' rule of change or signs. Okay. What coefficients am I using? 1, 1, -7, -9, -18. Anybody have a root to offer up? 3. So 1, 3 times 1 is 3. That gives me 4. That would give me 12. The difference there is 5. That would give me 15. Difference of 6. That is 18. So I've got 0. So I got 1 root. Let's put them over here. So x is equal to 3. Okay, now I'm going to do this again, but I'm going to use the leftover stuff. Anybody have another root to offer up? -3. So I've got 1, -3, 1, -3, 2, -6, 0. So there's my other one. X is equal to -3. Okay, do it again. X squared plus x plus 2 is what I've got remaining. We're supposed to get 4 roots. Now that could be a combination of real or complex numbers.
Or imaginary.
I'll be here till 4:15. You can pick it up anytime after school.
Does that go for me too? Please say no, because I won't be here after.
Do I have to mean it?
Oh.
So we've got x squared plus x plus 2. Think back to if you were going to factor this for real. What two numbers multiply to 2, a positive 2, but give you a positive 1? They multiply to a positive 2. They multiply to this, but they add up to a positive 1. 1 and 2 would give you 2, but they would add up to 3.
-1.
It doesn't happen, right? There's no. I mean, think about it. There's no such numbers. I still need those 2 roots. What will never fail me? Starts with a quad. Ends with an asterisk. The quadratic formula. A is 1. B is 1. C is 2. So x is equal to the opposite of b, plus or minus the square root of b squared minus 4 times a times c, all over 2a. When we plug the numbers into their spots, you get 1, 1, 1, 1, and 2. That means that x is equal to the opposite of 1, plus or minus something, over 2. Let's take a look at that radical. That's going to give me 1 minus 8, correct? Which means that is the square root of -7. So, I, radical 7. Got it? Okay, let's write these as complex numbers. X is equal to, let's start with this, and the positive. So -1/2 plus I radical 7 over 2. The other is going to be -1/2 minus I radical 7 over 2. So that, along with 3 and the -3, are all 4 of our roots. The linear factors, we'll do that in a minute, okay? Let people get caught up here first. So that's 2. going to put them into linear factors now. Okay? So these are all the roots. These are just whole numbers, rational numbers. These bottom ones are complex. Okay? I'll move on then. These are pretty simple to change, right? That's going to be x plus 3 and x minus 3. Okay? For the other one, though, I like this form the way it is here. Because what's the opposite of dividing by 2? Multiplying by 2, right? So that means that I'm going to get one of the factors be 2x. Let's move over the 1, so that would be plus 1, and then minus I radical 7. And the other one will be 2x plus 1 minus I radical 7. And there they are.
Wait, Mr. That's the same thing.
Oh, 1 plus. Sorry. Good looking out. Plus. Guys, that's all I've got.